Welcome to a new test and teardown video. Look at this homebrew stuff. Really beautiful. I think they do more or less the same, so I think I'm gonna cover all three units in the same video. They look a little bit different on the front. For example, this one is also a VHF millivolt meter. The same ranges, the same features and all that, but there's no connector on the front. There is, however, a connector on the back, and it is DIN connector. So I think this maybe is using an external probe. All I got is the end of the cable, and it just ends like this. So maybe I don't have the probe, right? Maybe we can figure out how this works by looking inside this one. So, it's a very different switch. This one goes super smooth, and this one is very hard to turn. It also looks like the meters, they're modified in more or less the same way. If you look at the dB scales, they're just printed by hand. So this one goes like +2 and stuff. So it's not the same place. I think this is done for like manual calibration, I think. So this is also VHF millivolt meter, and the input is here, right? And this one is low frequency. Many more ranges and the same kind of readout and all that, but what exactly is LF? Well, I'm going to find out exactly what is the range. But there's one thing I want you to see. Try and imagine you're playing around with very high voltages, and then, oops, you go to the 1 millivolt range. I mean, even if you're playing around with here and accidentally go that way, I don't know. I never see this on professional equipment. There will always be like a mechanical stop preventing you from doing this accident. Then you can only do it that way. So that means, okay, you're overloading the instrument, but it's most likely going to survive. It is not going to survive this. I hope this works, and I hope there's something cool inside. How about we start looking at this one, the low frequency one. So let's just power this up. Mains is applied. Why are we seeing some like warm up blip blops? So this is 1 volt. Is it RMS? I would imagine. Here is 1 kilohertz, 1 volt RMS. And it hammers out. Okay, so the 3 volt range. Ah, okay. Obviously, this is a classic. A classic way to handle meters. Okay, so this is 1 volt, and it shows a little bit too much. Okay, let's go. 1, so let's see if we can go 900 is here, okay. 876 500. Okay, let's go down to 200 and then. Aha. Ooh, that is funny. There's definitely something with capacitors and stuff. And then, ooh, that is pretty cool. Let's try and see how this turns out in the other ranges. Let's go all the way down to 30 millivolts. Yeah, okay. And 20. So that is 10. Okay. 9, 8, 7. Okay, so there's definitely, I mean, the meter kind of works. And that is 1 millivolt. Let me go down to 0.1, 0.9 millivolt. So it's the same. It's just reading about 10%. Too much in all the ranges. But this is of course at 1 kilohertz. So let's try again and look at the frequency response. Okay, back to 1 volt RMS. And then let's go down to 900. Okay, 800. So this is where we are. Okay, oops, difficult to hold the camera like that. Okay, so let's play with the frequency. That was 1 kilohertz. How about we just go up? So that's 10. 100. Okay, it goes. So that is 1 megahertz. Oops, and then it's dead. 4 megahertz, 3 megahertz. Ooh, it's a little bit. 3, 2, 1. Okay, 1, 2, and 3 megahertz. 4, 5, 6. So that is the frequency range when we go up. How about we just say 10 hertz? And then you see exactly what was expected. That is 5 hertz and it's dead. Okay, so all the way from 10 hertz or 20. Let's call this 20 hertz to 2 megahertz. That is what I would call it. So now we're inside. And what do you know? Look at that. That is some surprise. I did not expect it to be that nice and professionally done. So I guess you could buy these shielded cases, but it's just implemented really, really good. Wow, we gotta look in here. So to be able to open this, there's a screw down there to open that lid, that screw. So to be able to access that screw, we need to remove that case. We can't access the bottom screw or the front screw, so there's the only way to go into that one is to remove those 2 screws, lift it up, I guess. But wow, so far this is impressive. Absolutely plus points for doing it this nice. Wouldn't you agree? This looks pro. We are now deep inside. Took off both of the covers. I mean, this is absolutely amazing. Everything is made using mini mount. Just flying components. And it is that accurate. I am a little bit impressed. So this is the input, AC coupling, and the first kind of attenuator, some capacitors and some resistors and stuff. Let's see, speed up capacitor over some other resistors so you can tune for higher frequencies. And then we got some amplification, and then it goes to an output attenuator and then out. And then the signal goes to the other box. So I guess this is only AC amplification, and then this AC is converted into DC, because here I see rectifier diodes. And this is probably the calibration knob. I'll try and dial this in here and see if it goes more accurate. We got some diodes here. We got, yeah, got a few frequency compensations and stuff going on here. See, also on this So this capacitor is some local feedback for this transistor. Also note how the red wire, that is the power supply. See, there is a resistor and a capacitor for local feedback, local decoupling and filtering. Quite a lot of transistors, and it's beautifully made. And that pink one, that'll be the output for the meter. No op amps here. Only transistors. I mean, this is made by a guy who really knows his transistor stuff. And got a patient level above average, I must say. Now I really want to open the next one. So that was the LF one. Just to try this for fun. Now it's the LF version here is assembled. And of course I tried to touch this. And yes, it is calibration. Now, this is my 800 millivolt RMS input. And I tried all the other ranges and it's like spot on. So all I had to do was to calibrate it, and now it is nice and accurate. Yay! So let's take the next one, the VHF millivolt meter. And here it says RF. So I put my generator into 50 ohm mode. So now I think we are in 50 ohm kind of environment. Let's turn on mains and see what happens. Not a whole lot. So now we got this 0. Okay. How much 0 do I need? So I just put it for perfect 0. And this is 800 millivolts. Ooh. At 1 kilohertz. Obviously. We shouldn't see a lot at 1 kilohertz, so let's go to 1 megahertz. Haha, already. Okay, 1 megahertz. Okay, let's crank up the frequency. So that was 1. And that was 10. And that was 100. Okay, 200, 300, 400, 500. Okay, but I think VHF is up to debate how you define that. So that was 100. Let's take 100 and no, 100. That is weird. Okay, 100. And 10 and 20, no, and 30. See, I'm poking a little bit around with 30, 40, and then 170. Yeah, that's definitely. I think it goes pretty well up to 100, and then it goes a little bit into unstable mode. Maybe there is some oscillations or some stuff that is not working perfectly fine, but I mean it. Okay, that is what it. Look at that. Hello. This is what we got. There's a loose connection. Hello. I think I got this on tape, right? It just went down and I didn't touch anything. It's definitely not a frequency kind of thing. Now we're all the way down to 1 megahertz again. And it's kind of dead. So that was it. I blew it up. Yep. Hello. No. So that is a good excuse for open. let's get some more light in here. So this is the VHF millivolt meter version. We're playing with that one right now. And this is the internal circuit. And now I think I figured out what is going on with the probe, because the last one is using an external probe, and that will be the circuit for the probe. So that will be two AA119 germanium diodes, and one is just connected to a ground, and this is of course for measuring the DC drop in the diode, and it's also directly connected thermally to the point where the sensor diode is connected to that point. Of course, if you put this diode somewhere else in this circuit, you don't have this thermal compensation. So this is exactly what the zero adjustment is doing. So he made this input here really small and effective for very high frequencies. I'm actually quite impressed with the whole setup here, and I think I found the loose connection that was in the sensor pin with the 3 resistors, because I resoldered that joint, and now I can't recreate the loose connection I had. So that will be the sense probe for the other one as well, right? So here is the detector and the compensation circuit that goes to an op amp, and that is of course compensating the offset using the voltage in that other diode, and the gain is adjusted with this resistor network. So there's only one set of resistors for gain adjustments. We got a little bit of diodes and stuff. We also got some diodes here. This is driving the meter, so that was probably the meter. The meter rectifier bridge. So that's probably where I would dial in the calibration. This is running off plus minus 15-16 volts, just using Zener diodes and 2 transistors. Nothing fancy pantsy here. NPN and a PN3 transistor, super easy. Yeah, that's actually what it is. So I believe this is indeed a homebrew construction. Also, I've seen those pins before. I've also seen those chokes. So that will be a DC filter choke, and that is like Storno components. And also those PCBs look a lot like Storno PCBs, by the way, or at least those test pins or those interconnect pins. They look a lot like Storno, but what you see here is actually it's like a test pin at the same time as it's an interconnect. So you can stick in a test probe here and it's going to stay there. So you see the holes. Well, that's pretty neat. Yeah, let's do a little calibration of this unit now. So that will be 800, right? Let's just try and play with. I bet that will be the meter. Yep. Well, that is exactly what it was. So that is 800. And I think we can be happy now. Oh, by the way, let's play with the 0 here again. See, here it's not so super critical, but the finer we go here, see, Ooh, now it's that magic point. And now if you just put it just where the needle is a little bit affected, so close as you dare. So this is 10 millivolt full range. Let's see if that works. So that, I believe, is 5 millivolt at 1 megahertz. So that means my... Ooh. So my buck is back now. Or is it that one? Okay. So I didn't find the problem. This is the problem. See? And then I go up. Okay, so this is the pot. Okay, it was the pot all along. So what if I put this for 5 now? Because I know I got 5 input. Turn off the input. Okay. Well. So it's not super accurate at... So that is 30. No output. Okay, let me give it 20 millivolt RMS. Boink. Okay. So at the super low millivolts, of course this is not accurate. The whole thing with the diode and all that. What did you expect? But anyway, it gives you an indication about what is going on. Is it more? Is it less? And I bet this is more than you need really to find it and repair stuff. So I expect the next one to be exactly like this one. But let's have a look. And we are now inside the last one, the VHF millivolt meter with external probe, and everything I guessed is accurate. So that is the external probe. It's connected to the same point. It is exactly the same PCB. However, I think this one is made before, because everything here seems to be a little bit older on the date codes. I think this one said 73. So look at that. And it's an ICL 8007C. What the heck? And that is from 74. Wow. But other than that, yeah, the circuit is identical. He's been playing around with the attenuator resistors, probably to calibrate something. And also you see the trim pot here is a little bit annoying. The previous one was a lot better. And a few things is actually a little bit better when we look at the shielded cables all the way even to the meter. Probably not needed, but it's just really almost what I would call all the way. Everything here is quite good. I also like the way that the wire is carefully mounted. No matter how hard you yank in the wire, it's not gonna fly anywhere. And it goes to the switch and it's double. Well, okay, the color coding here is a little bit funny, but who cares? It doesn't matter. That is all right. Yeah, so that is definitely possible to make this one work as well. Just make an exact replica of the probe in the other unit, and then this one will work as well. I am sure about it. I think I will close the lids and put them on my little inventory list. So thank you for watching. I hope you had fun. Come again tomorrow. So now I've been messing around with this one and trying to figure out the ranges, the accuracy, frequency ranges and all that stuff. And then I do actually find something that is funny. If I go a little bit out the range like positive, I mean signal Y, so that is back to 200 and 300, 200 and 300. Okay, that works constantly. So let's just try 400. Let's go back to 300. Ooh, you see, we got a sticky. And then I go back to 200, and then back to 300, 200, 300, and it's constant. 400, 300. See, sticky, sticky. And I thought, okay, is my generator broken? So I put on a scope to verify. Okay, we don't mess around here. The signal generator is working. All right, so what I found is something else. That is the date this unit was made. So it's from 81. Haha. And I wrote down the frequency range here on the back, so I know how this one works for the future. So this is from 81. What do you know?